Right, so again, welcome to today's session. We are in part 2 of 4 in our kind of our month-long ARM and statistics series of webinars. If you missed us last week, we went through a presentation, just really all in PowerPoint, talking through the various stages of data analysis. Primarily, kind of introducing the idea, which we're covering today, that once you get data recorded, instead of immediately jumping into analysis, there's a couple things that have to happen. Today's focus is kind of the step 1 here on the slide we can see here, where you really want to confirm what data was entered into the software. Make sure there's no typos, and check for outliers, things like that. Then, once that is finished, you can begin to review the data as far as testing for your assumptions of ANOVA. And we'll cover that on Thursday's presentation in a couple of days, where we do our data review. And then finally, the analysis itself, generating the report, and we'll look at the various options and choices you have for the analysis that gets performed in ARM. That'll be our 4th and final session next week on the actual kind of reporting, running the analysis itself. So again, today here, our focus is on that first step, really right after the data has been entered into whatever software that if you've written the notes down and you're just transcribing, or ideally, maybe you're using a data collection tool, so that way you have that software available immediately when you're taking the notes, or so we can kind of analyze, check what we're putting in right away. That's going to be of most benefit to us. And so I've kind of coined that term. I don't know how standard it is out there in the world, but at least especially for kind of explaining these different phases, I really felt that this step needs a name, and data confirmation is the one I use, at least. Really just wanting to get, once this data is in, we want to make sure, confirm that this data here that we're about to analyze is correct. That's the first step. If we introduce some issue with this data before we even analyze, we're just off on the wrong foot. So that's really the hope and the goal here. So this was our slides from last time. We won't spend the regurgitating everything, but the main points we talked about that we'll see today. There's a huge benefit to reviewing this rating immediately when you're at the trial site, instead of having this be a days later type of process to do. We will be talking about outliers, how we can find outliers, and they really are just data values that are outside the expected boundaries, that they are abnormal in some fashion. They're larger or smaller than what you would typically expect the rest of the data points are. But that doesn't mean that we can't have them at all, but it's great to look at them, make sure they are accurate. So those can exist, but of course typos should not. So naturally, that's part of our decision-making process. We want to eliminate incorrect information, even if some information seems a little odd. As long as it's correct, that's what we want. All right, so that's all the PowerPoint time we're going to put in here. As promised last week, we said there was going to be light on ARM, but the rest of our sessions, much more of our software. So that's what we'll stick to here. So I'm just going to go through kind of a few different tools that are useful for this data confirmation step. in ARM. I think I'm just going to kind of go through the order that maybe I would use them. There's maybe nothing necessarily magical about the order. I think they all have their uses, and if you find a different order of which you can use them, totally fine. We're not trying to rank them or anything, but just kind of go through them logically, at least the way my brain likes to organize them. So first one, I guess, just that one comment we had from last time about your acceptable range of outcomes, which could be done even before you take the data, is just, kind of having an idea of the assessment itself that's going to take place. What is a rational, normal range that you would expect? And kind of just having that in mind as you're going about the assessment can help catch when you're reading your assessment of some sort comes up with a number that doesn't match what you were expecting, can help kind of catch right off the bat. And just to show kind of in ARM where some of those things would land, we do have here in the header portion, the top half of your assessment where the assessment gets described, we do have the rating minimum, maximum, and interval row here. And that can be helpful to define that range of outcomes. The key would be that this minimum and maximum values here would be true hard limits that we have. So in our case, my made up assessment that we're pretending we just took data on is looking at disease coverage on our leaves. And it's expressed as a percent of the area of the leaves of our plant. And so in our case, you certainly could define a minimum and a maximum being a proper percentage. We can't really possibly have a value that is less than 0. You can't have a negative amount of area of a leaf being covered, and you also can't have more than the area covered. So that's one area. If just by the nature of your assessment unit, you have some hard restrictions on that, this can be useful to put that in. And sometimes it is found in your unit itself. So if I bring up the rating unit list, you will see some of them do have the minimum and maximum already filled in. And that's percent of incidence. Rating scales are a common one as well. If I'm doing a 0 to 3, those are the only values that are even possible between 0 and 3 for my index rating. And so those are kind of hard-coded, if you will, right into the unit. So then ARM can detect and stop us from typing something incorrectly. So I'll hijack this 10 here. And if I accidentally, as I'm entering in the data, put in a value that does not match that boundary, and here I've got that 0 to 100, that proper percentage, then ARM will stop me right in the process of entering the data to say, wait a minute, this value you've given me makes no sense. You've defined a limit between 0 and 100, and now you're trying to tell me that this plot is at 110. And that shouldn't be possible. So that's one of the benefits of this interval, just to catch even right when the data is being put in, catch a typo or things like that. So this is prompting me to change so I can identify that, oops, it is supposed to just be 10. And then I can correct that and move on to the next assessment value, just right as I'm entering the data. So there is a question about, kind of having 0 to 100 already in the list. So percent of area, it is kind of a little surprising to me that we don't have the 0 to 100, but perhaps there's another use of this unit where it isn't a strict percentage. Maybe perhaps if you use this to calculate relative to your control or something, and the unit still would kind of be, well, there you'd probably want a percent control instead. I would say in that case, like if you say, hey, every time I'm using percent area, I would want that 0 to 100 there. One way to make that be real, we'll say in your ARM, would be to add this unit to your favorites. And then you can go to your favorites list here and edit your list. So then when I'm looking at my favorites list, I can in ARM, there's an edit menu to edit your validation list. And that should select the rating unit because that's the one I have open. And it will open up this personal list almost as if it's in Excel. So then I can put in my 0 to 100 if I want that to always be used in that fashion on my computer. And that's why it's kind of possible to do this, is I'm just editing my local favorites list, not the master that everyone sees. Oh, and there's a good comment. Thank you. Of an example where maybe it could be over 100 if you have overlapping leaves or something, and you're more rating your ground cover or something like that. So thank you. That's a great example. Maybe it isn't always true the 0 to 100 if we're using a ground cover assessment instead. It's a great example. But you would in either case, if you in your research know that every time I use percent area, I'm going to have it in this proper percentage use, you could certainly edit your your favorites list on your computer to make that happen. Great question and great example. Thank you for that. So that's really just kind of how to set up your boundaries if your assessment allows, if you have that type of assessment. I did show, let me just show real quick the rating scale. I'll just go into a third column over here and choose like the 0 to 10. So some of these rating scales, they utilize the interval. So that's going to put a limit not just on the upper and lower bound of a 0 to 10, so I can't put in 11, but it's also going to limit the interval within this 0 to 10. So a 1 here says I can't have decimals, for example. So I wouldn't be able to do 1.5. That would not be valid because the interval is set to 1. So it would start at 0, and all of the valid values have to be every one number, scale here in this case. So it's going to require that I'm choosing, in this case, integers, just round numbers with no decimals on them. In this particular case, the 0 to 10. There's some other ones that allow more. Here, this nodal corn rootworm scale that has 0.01. So I have down to 2 decimal places even. I can use that. So here's something like a 2.15 is perfectly valid for that scale. So that rating minimum, maximum interval, that's just kind of how we can kind of set up those parameters of what is valid as far as our values that we are entering for this assessment. Okay. I guess sticking with the header for another minute, I'll just delete this data column off. Don't really need it. A couple other parameters that we can look at in the header, that some fields that might be of interest. Really just thinking about, even before we need to spend much time looking at this data, it would be valid to ask the question, is this assessment realistic or viable for us to analyze in the first place? So, are we achieving the expectations, the objectives in our study? Does this column have any value to add to that? So the example that I am thinking of would be in our pest section, perhaps. Here we go, pest density. That might be a field that we want to look at as a good first starter here. Maybe this assessment, there just wasn't enough pest pressure to even matter. And so really we don't need to spend time investigating an assessment that'll never be used in the summary. That'll never provide us any conclusions that we can draw from if we don't have something like that met. So even just starting here in that header to review something like your pest density or any other objective that matters, we can just move on to the next assessment if this one doesn't even have that certain level. So I've got a 1.75%. I guess another field that would maybe matter in that example would also be your acceptance level. That could give us some guidance as to what this we're hoping for, what the pest density we might be wanting is, because that acceptance level gives you a threshold of what's acceptable or not, if we're not quite sure for this one particular trial. So just another thing in that header to get an overview of. And the reason to show that is we have a field. Is it hidden for me as well? There we go. I want to highlight the data reliability field that we've added here in the last year or so, found near the bottom. And this field is useful to real quickly kind of designate, categorize your columns. Really the whole idea for this is just to categorize whether the data in this column should be used to make conclusions, to draw conclusions. And so we can, since I am sitting here, inspecting this trial, making this determination, it'd be really great to document that so it's very clear to others who might summarize later, or clear to myself later if I need to run a report, to know which columns are worthwhile and which are not. So the idea of this field, in some regards, is a simple yes or no. Should you use this column to make conclusions at all? Yes or no? That would be kind of your first two options here. If the answer is no, we didn't have enough pest pressure, something went wrong during this assessment, and we really can't use these results, any sort of reason why this column won't be useful in our final analysis, we can mark this to exclude. No actual action takes place. We're not throwing out the data or anything like that. We're simply marking down, jotting down that designation to communicate that to others. And you'll see once I picked something, I also get this little icon over the data. So as you get used to making this designation, there's actually shortcut buttons here. And you'll see when I click on a different icon, it becomes colored, so it is selected. Excuse me. And that data reliability value is updated. So whether you're picking from the list or just clicking on the icon, same result. This is just a fast way to make that designation. So one means use it. Excuse me, one means do not use it. That was the little red X. Two is a check mark. Everything's fine. This column is perfectly useful. There's one more option for best. That's that little star. The idea there is just, if you think of the full trial, and maybe there's several assessments that I do over time, and I want to point out the best ones to look at. So, if I'm going to have a colleague review this trial to see what happened, you don't have time to look at everything. I want you to look at just this one column, or maybe these three assessments really show off and best encapsulate what occurred in this trial. That's really the idea behind this third option of best. Still just usable. Both of these mean usable. Everything is great, but there's just kind of a special designation if you give it that value of 3 to say this one's great to use, and in fact, it really shows the results of the study. It summarizes things real nicely. So if you're gonna put this in a PowerPoint slide, grab this assessment. That's the one to make a graph of, or whatever. So real easy. One of the reasons we made these buttons is it's real easy to just make this designation. So I think it's real important in this process. If we're going to kind of look at the data, confirm what values are here, putting that data reliability as kind of the last step as you move on to each column is just a great habit to get into. And then you can see later on, you can see that the data has been looked at. So it's just a nice way to stamp, in some regards, to kind of stamp down that someone has looked at this. So if later on this trial is opened up in a week, 2 weeks, in thinking about preparing final reports, there is no question, well, has anyone looked at this yet or not before I go to analyze? I was very clear. I've got a bunch of check marks. Somebody has confirmed my data. I'm ready to move on to our next step instead. Last but not least, real quickly, just to tie into this idea of this exclude, if something's wrong with this assessment, whether something happened during it, we didn't have that density, whatever the case may be, you can, in the ARM action codes field, this is lots of options of things you can do in the action codes, but specifically there is a section for identifying, kind of marking down data to not exclude, data to not analyze or exclude our data. And so variety of things you can throw out. We can just not summarize the check. We could throw out a particular treatment or a particular replicate. But most useful here in this idea of just knowing that this entire column doesn't provide us value in analysis, we could put in the ES action code, and that's going to remove this column from any summary report. So any ANOVA that we run, this column just won't even be visible. So if we really want to hide it in that regards, we can. Or maybe we do kind of need to have it reported because it is an assessment that occurred. So we do want it visible. but we just don't want to run any statistics, then we can use probably NM would be the best choice there. No analysis occurs on the report, but this column is on the report, and we just simply calculate our treatment means. So you can see what happens, or what happened with the assessment, but no analysis actually occurs. And going back to the ES, so ES is really talking only about ARM and ARM summary reports, like the AOV means table, the assessment data summary. It just won't be visible there. For ST, if you don't want this column to be included in an ST analysis, there's a separate code for that. So probably in likelihood, if ES is used, because it shouldn't be in a single trial analysis, you maybe also don't want it in your ST, your multi-trial analysis, you would put in both codes. So if you pick this first one, ES, you can also add in, you can either just hand type if you know EST, just put a space, and you can do a second code, and both of those will be honored. So something like this, both in the summary across trials as well as ARM, this column is just invisible. It just won't be included in any analysis. So that would be, you do need that second code in order to also exclude it from ST. Great question. And then as far as going into the ATD, this data still will be exported into a database. So the key would, of course, be this information, the designations in your ARM action codes will be there as well. So downstream, if you're performing your own analysis with the data, you might want to make sure, check to see, is the action code marked as ES? If you start using that nomenclature, you could have your downstream reporting also take that into account. Because yes, it still will go into ATD, just with that all the same information available in the database too. All right, one more question, I think tied to maybe a little bit of this action codes when you are calculating TIO, I think that's incidence, isn't it? Tools transform, TIO, I think is one of these incidents, right? Yeah, that sounds familiar. I think that's an issue we would address with our developers. If you create an incidents column from this column number 1, let's just throw it in column 3. You see how when you create a calculated column, ARM fills in a lot of details from the original column, since most of those apply. Yeah, I'm thinking your request is the fact that rating type really is not area anymore. In this case, it should be incidence. I think we'd have to consider just, I don't know if this is the reason we don't have it automatically occur right now, is PESINC is pest incidents. I don't know if we get in trouble, if there's any other use. If I go back to this transform dialog, percent incidents, does that always imply pest incidents or not? That might be the one reason we don't have it autofill, but definitely something we can think through. I'm just jotting this down here to follow up and play with it a little more, see if that's been requested before and if we've done any research on that. With the TIO transformation. Great questions. All right, this is gibberish, obviously, not really an incidence type of column, so let's just delete that out. All right, let's go back. We haven't done the analysis yet, so actually maybe I should just clear this out, and then we'll see if I remember to fill it in the end or not. Okay, so that's the assessment header, some things to look at documentation-wise. Let's dive in to the tools we have for kind of looking at our data. So, or kind of pretending I just got done filling in this assessment, and what we can do to really kind of take a look under the hood, if you will, and try to visualize the data that we've entered. Because certainly just scrolling through a list of numbers, somewhat limited. We could maybe spot some odd things, but not quite as reliable as if we can visualize what we have. So over here on the properties panel, you'll find that at the right, we've got a few different options, some tools, things like that. If you don't have the properties panel visible, it might look more like this. And you'll find the properties all the way over to the right, written kind of up and down. There's a few different panels, and we'll end up seeing a few different ones of these in the coming sessions. But right now, I want just plain old properties. You can click on that panel, and if you want to pin it down so it stays visible or not. And what I'm interested in is this box that says tools. These are going to be useful to us today. And the number one item that I like to start with here is actually at the bottom, and it's called assessment map. I like to call this kind of one of the best kept secrets in ARM because really powerful, but it's just not quite as flashy of knowing where to find it. So this assessment map, what we do is we draw your trial map of the trial location here, but instead of coloring by treatment or your replicate pattern, the coloring is a heat map of the assessment values that we've entered. So we take the smallest value, and that gets the almost white, really light green. Then the largest value that's been entered is pretty much black, and then everything's a gradient within there. So this helps us visualize the assessment for any extreme values, low or high, and really gives us some spatial patterns as well. If any sort of pattern exists in a, maybe this left half seems pretty low assessment value, other than this spot in the middle. You can try to catch something that seems a little odd that wasn't maybe as clear when you were taking the data. Starting right off here, I've kind of rigged this data up. There's a very loud outlier that we can see here. Plot 904 is just very dark relative to everything else on the map. So what we can do, if I click on that plot 904, the coloring changes just a little. We turn on this color by current treatment option is turned on when I click on the plot. And what that's doing is showing just treatment 4, which is the treatment on this plot 904 that I clicked on. It colors only that treatment in the different replicates. So this can give me a nice idea of how consistent this treatment was. And in this case, I notice it's really only high in this one replicate, which seems very strange. If they were consistently high, then we just know this treatment performed poorly or performed well, depending on your assessment. But it really seems unusually high in this replicate. So what we can do, if I double click on this plot, ARM will close the map and move my cursor to that data point itself. It brings me right to plot 904 on the editor. And I can see that I've got 120. Very, very large value. In fact, impossibly large in this case, as we discussed. This is a percent area, and we were looking at leaves. So I know that I can't have more than 100% of my leaf being covered with a disease. So we've found a value that clearly is not right. This is kind of where the timing of when we're doing data confirmation comes into play. I can be confident this is wrong, 120 cannot possibly be right, but the problem is, what is the right value? It could be just 20, or it could be 10, or maybe I meant 12. If we just kind of scribbled it down, it's not legible on our paper. If this data was entered in a week ago, be pretty hard to remember specifically what 904 looked like to know what to do. So that's why if we're taking this data here with some tool where we can do this process while we're still at the trial site, we can confirm what this is supposed to be. So let's say we know it's supposed to be 20. Maybe that paper was clean enough and I know I just mistyped. We get lucky, everything's great. I can make that adjustment. And if I just load my assessment map again, now that we have a more realistic value, my map actually starts to show us something. That extreme value was kind of washing out everything before, but now we're actually kind of getting somewhere here. A lot of times what I'll do is just start in the first replicate and just kind of click on each plot in that first replicate to just get a sense of each treatment. How consistent was it? Treatment 3 looks maybe a little inconsistent. Sometimes it's very low, but we've had a couple of replicates where it's at least somewhat high. The untreated check is consistently high. So you can just kind of go down one by one to start to get a sense of what it's telling us here. So I've got another large value, plot 203. So let's just double click on that to go there. I've got myself a 65. So this is perfectly possible for a 65 to occur. So we can't just rule out the fact that obviously this is wrong, but it is quite large. It does seem extreme. So do we, what do we do with it? Well, another tool, if we want to get a second opinion maybe on whether this is unacceptably extreme or what we're looking at, right above that assessment map button, we have a Box-Whisker graph. So this kind of the quickest way to get a graph in ARM. It doesn't ask us about treatments or header fields. It just draws us a graph. Just some basic definitions. If you haven't used a Box-Whisker graph before, we're kind of going treatment by treatment. We generate a box based about the median. So the top of the box is your 75th percentile, and the bottom is the 25th percentile of your data, of all the data points in this assessment. And then the whiskers extend out above and below to any other values in the data set that is not calculated as an outlier. And we'll get to the outlier in a second. The dashed line is your mean, so that would be your average. The solid line is your median, which is your 50th percentile. So the solid line is, you know, kind of the middle of each box. So not the middle of the box, but that's kind of where you start to calculate those box values there. That median is the middlemost value. And if you compare that median to the mean, you can kind of understand a little bit of the distribution of that particular treatment. So if if those two are pretty much on top of each other or real close, then it's pretty balanced distribution. Whereas if you have a really big difference, that tells you there's some skewness in treatment 4 in this case. So in this case, that mean is always, you know, pulled down or pulled up by an extreme value. In this case, there's a low values pulling down that mean. So the mean being much lower than your median tells you that there really is some skewness where some low values are pulling down that mean. Kind of the opposite here with treatment 5. You've got the median down here, and that mean is being pulled up by this higher value. It's like probably about 20. So just getting a sense, treatment by treatment, how consistent it is, its distribution. You can also just the general height of the box, that gives you a sense of the level of variation in that treatment. So we can see treatment 3, pretty low variation there with the smaller box size, whereas treatment 2 looks like it probably has the most variability. And 1, 4, and 5 are all about the same. If you remember from last week that the amount of variability, that's one of the assumptions of ANOVA, is that each treatment has more or less the same amount of variation. And so we'll see in next session how we can actually test for that and get statistical tests and really inspect whether we believe that is true or not for the data that we're looking at. But from here, it looks like it's fairly close. Perhaps maybe that 2 and 3 would be the biggest reason we would fail that test. But the Box-Whisker just gives us that kind of first idea, the first feel for whether that might be something we have to worry about or not. So back to the outliers. There is an outlier here on treatment 3 that is marked with an X. So the Box-Whisker calculation for an outlier is if it's 1.5 times the height of your box away from your box. So taking that height there, add another half of it, is that this X sure seems far enough away from the rest of the data points that is considered an outlier. So if I hover over that X, ARM is actually going to tell me that that's plot 705. Let me look at I think I need to change my axis options. Let's go up to 100. There we go. Yep. I'm like, I think I'm missing something because we talked about a 65, and that clearly is not a 65. So there we go. We also have another one, plot 203. So that's the one we were looking at a moment ago. That one clearly is the 65 assessment that is way higher than everything else. So kind of just the difference between those two. We were using the assessment map. We could see compared to all of the assessment values when there's a really extreme value, high or low, kind of really popped out on the map. The Box-Whisker tells us the same thing. We kind of find the same value, but then it also found one more value that I wouldn't have thought to look at either, this plot 705. Because when you look at it, it's only, what, I don't know, 30, maybe 25. That in and of itself was not interesting compared to all of the other assessments. But within the scope of just treatment 3, wow, a 30 is pretty interesting. Everything else is under 20. So that's kind of the benefit of using several of these tools, is you just get a little bit different cross sections of the data that you're looking at, to find values that could be outliers, that are unusual. The important thing, though, at this point is, we're trying to find these values and we want to investigate them as far as, do we think that they are okay or are they inherently incorrect? Just because it's unusual to see a 65 doesn't mean that we should just automatically throw it out. Well, that's too big. It's an outlier. I don't want that data in my analysis. Well, that would be not correct to do if truly at plot 203 we had that much disease in that plot. By just how things happened, if it's totally valid that occurred, that should matter to us. So we can't just blindly throw it out because it looks weird, but it gives us, these tools give us the focus to go inspect and take a closer look at what happened at this plot. So the phrase I usually use, unusual data does not mean unusable data. Is kind of the point I'd like to hammer home. Sometimes it's just real easy. Hey, there's this calculator that tells me there's an outlier. I can just now go and ignore it. Let's just go throw it out. That 65 is wrong. Let's throw it out. And I'm just advocating for, as a researcher, you've got the experience and knowledge to say, well, let's look at what happened here. It's unusual. We need to decide, is it unusable? Maybe, something happened in this plot unfairly compared to all of the other plots. It doesn't fit in with our objectives. It's not encapsulating what we really want to learn about. And so it is not valid. We can throw it out. But maybe it is perfectly valid that this occurred. And if we're in the field when we're looking at this value, we could take a picture, put in some more documentation, so we can really understand that no, something unusual happened, but it's within the range of possibilities for this treatment, evidently, as we can see. So if we do decide, though, that this value should not be used in the analysis, we don't just have to delete it out of here. Back over here on the properties panel, down at the bottom, there is a section for the assessment. So this is related to the cell that you're clicked into. So you can see I'm talking about the assessment for plot 203, column 1. And there's a spot for a comment. So you can put in, whatever notes you may have. Really useful to just explain to somebody what you found with your investigation. There's a spot for a barcode or GPS coordinates. like I said, you could take a picture of what happened as documentation, and you can make an attachment here. But for throwing out this data point so we don't analyze it, the checkbox here says exclude. We did recently rename that. It used to be called damaged. So if I call it damaged again, that's the reason why it's been named damaged forever, but we generalized it because it doesn't mean that necessarily that the plot was damaged. There could be any number of reasons why. But what happens when you turn that on, I'm just going to click away so you can see a strike through comes through on the screen. It's just a visual indication that that 65 is not going to be used in the analysis. ARM is going to treat plot 203 in this column as if it's just a period, as if it's an empty, missing data point. But the nice thing is we can keep all of our original documentation of what happened, but not have that information included in our analysis. And you'll see that updated. If I go to my assessment map, that plot 203 is now just white. So it's as if it's a missing data point. So it's kind of hidden, if you will, really from any tool or analysis from then on out. So again, that's the exclude button over here on the assessment to mark a single value. If you need to throw out a whole treatment, or maybe this whole replicate, something happened in that entire replicate makes that whole thing invalid, that would be back in the action codes. And that was these, ET to exclude treatment, or ER to exclude replicate. And then you just put in the number, replicate number, treatment number to throw out. One thing I did not show on the assessment map, we've got the same tools as on your trial map. We're not changing the randomization, but if you go to the options tab, you can draw the map to true scale. So this changes the way the map is drawn to be more realistic. It uses your plot dimensions, any of your alley widths, things like that you have in settings to draw it really according to the real space in the field. So this, I think, is real useful for visualizing the overall assessment. You can see, any spatial effects that are taking place. So a corner is a corner of the map higher than the rest. Is there a line running through the middle that's really low? Or, maybe we had an irrigation problem. Things like that maybe aren't so obvious just by looking at a list of numbers. When someone comes in from the field with their data, here we can visualize actually kind of what it looked like based on those numbers. So again, that was just show true scale on the options there. Kind of running out of time. If there's any questions, send those off. I do just want to show, we've talked about outliers quite a bit on what to do with them. So that Box-Whisker, when you're on that graph, it's calculating outliers for us. That's one method. There is another method for calculating, just again, trying to find an outlier. Right now, that is on the column properties panel. So if I make that visible, there's some statistics and things you can kind of ignore for now. But at the bottom, there's a box for outliers. So this is just going to calculate outliers based on either that same Box-Whisker method but we do have another method just based on standard deviation. So taking your whole column based on your grand mean of that assessment, calculate the standard deviation, and any values outside 3 standard deviations from your grand mean would be considered an outlier. Or you could also do plus or minus 2 standard deviations. And if you pick that and press Find Next, what happens, ARM just moves the cursor to the next value. So now plot 801, this value of 40 is marked as a potential outlier. And I just keep press Find Next. It's only found the 1. I could be even more restrictive. I'll click somewhere else and do plus or minus 3. Say Find Next. It says, nope, it didn't even find any. So that's just another way, just depending on how you typically want to find outliers. If your data is perfect, perfectly following the normal bell-shaped curve, even the 3 standard deviations from the grand mean, if you had 100 data values, that perfect bell-shaped curve will still have, is it 99%, 98% fit within 3 standard deviations? So you'd still have potentially like 2 values that could be outside of the standard deviations, even in the perfect, a perfect normally distributed curve. So it's not perfect. Finding an outlier does not mean you need to get rid of it, but it's just a way to find extreme values that would be worth investigating. We do have one on the column diagnostics as well. I'll just unpin these just real quick. There is an outlier calculation here, and it's based on the maximum standard residual, I think is what that stands for. It almost never finds an outlier. It's a calculation that kind of takes into account that idea of a normal distribution still has some outside of the standard deviation, so it tries to adjust for that. So it's super conservative of an outlier calculation. So it's literally hard for me to like rig up data as I'm entering it in to try to make an outlier. It's even hard for that to pop up. So it's useful in that fact that if you encounter the diagnostics telling you there's an outlier, it means business. It means there is something odd there with that value. But as far as I think our step here of confirming the data, not super reliable. I think it's more useful to find some values, and then you can do that analysis yourself to say, okay, this value has been flagged as unusual. Is it usable for us or not? And then just because I want to make sure I didn't forget, once I've reviewed this column, I want to make sure to give that reliability designation for moving to the next assessment I might need to review. All right, well, that is time. Fast and furious. Thanks for the questions and participation throughout. Like we've said, just part 2 of 4. Hopefully you'll join us again in just a couple of days for the data review. We'll talk about assumptions of ANOVA. So until then, thanks everyone.
Thanks for the session. Bye.
Thank you.
Thanks, Matt.
Thanks, Matt.
Thank you. Bye-bye.
Thank you. Bye-bye.